I'm Silas, and this is my presentation on background on the Pumpkin Hollow deposit in Yerington District of Nevada. So the purpose of my research is to better understand some of the geological controls on what are known as iron oxide copper gold deposits. And essentially these deposits are, can be and have economic grades of iron oxide minerals, magnetite, hematite, and copper and gold. And so some of the questions that I'd like to try and answer are how many episodes of hydrothermal fluid flow may have occurred in the Pumpkin Hollow deposits, and how do we see this kind of manifested in the samples that I'm going to be looking at, such as the core samples and the thin sections that I'll produce, etc. And so something that's really interesting is when we're doing research on these types of deposits, we really want to know and have a better understanding of the types of alterations that were introduced, and how they kind of controlled what economic metals of interest we're searching for. So to answer this question, I'm going to investigate the mineralogy, some of the alteration on the deposit, mineral textures, and mineralization in drill core samples. And to the left, you just see a little figure, and this is going to be just kind of the global distribution of iron oxide copper gold deposits throughout the world. So the locality of my project is actually in Nevada, and we're going to be located in Lyon County, which is right here, and it's going to be in the Yerington mining district. And so that's right here. This is the Yerington mining district, and it has been historic for copper production, primarily from both porphyry and skarns. And the Pumpkin Hollow is producing copper actually right now from its underground workings, which is pretty interesting and really neat. So some of the data collection will be primarily petrographic analysis. And on the left, I just have one of my spreadsheets I was working on, and it's just mineral identification through the use of polarized microscope. And on the right is actually reflected light microscopy. And we see the mineral right here, this dark mineral. That's actually magnetite, which is an iron oxide. And here we see, or what I thought I saw was chalcopyrite, which is a copper iron sulfide, and pyrite, which is an iron sulfide. So some of the different directions I'd like to try and go in with my project include looking at a specific group of minerals, and those are the epidote group minerals. And what I would like to look at is, are they common alteration products in iron oxide copper gold deposits? And this can help us determine some of the conditions in which this IOCG specifically formed. And narrowing that down is essentially what I hope to end up with through my research. And so, as we can see, they can have a range of major, minor, and trace element compositions, which I can use scanning electron microscopes and narrow down what exact elements we're actually seeing in the epidote group minerals. And so their varying compositions shed light on variable hydrothermal fluid compositions. And essentially this means that depending on the chemical composition of these epidote group minerals, we can actually identify what minerals may have been in fluid in this hot thermal fluids as they're moving through the deposit. So as I mentioned, some of the methodology, I'll use polarized and reflected light, and I'll use these to observe habits and textures and also mineral associations. And later on, I would like to use scanning electron microscopy to get very precise chemical compositions. And yeah, so my results, I'm hoping to narrow down the spatial and temporal relationships of epidote to the formation of the Pumpkin Hollow deposits.